Hey, my name is Eva, and this is Blond Quantum, the podcast that breaks down quantum technology into real world business impact. Here, we make the complex simple. No equation, no overthinking, just insight, innovation, and a bit of humor. So don't worry, you don't need a PhD in physics to follow. In each episode, I talk to founders, scientists, and investors about how quantum is reshaping the industries today, not in some distant future. Oh, and if you hear a black cat purring in the background, that's my co-host, very alive Schrödinger's cat, joining the conversation. Her name is Moon. Let's get started. Welcome everyone in the next episode of Blond Quantum. Today with me is Joe Spencer, UK Director of Global Quantum Intelligence Platform. Joey, thank you so much for being with us here today.
Yeah, thanks for inviting me, Eva.
Last November, I had the pleasure to host another member of GQI, Andre Koenig. It was actually one of the most viewed episodes of Blond Quantum so far. So no pressure, but here we are. And then with Andre, we spoke a lot about the global race of quantum and all of the geopolitics that are involved in it. Today, I wanted to change a little bit of the direction and talk about something different, something that you had a lot of experience with, which is obviously defense. You're based in the UK, right? So tell us, how serious is the UK about the quantum as a defense capability versus just a research priority?
I would say, like all nations, we take it very seriously. The UK has a rich history of quantum, probably one of the first early national programs deployed in 2014. And defense was really sort of at the start of that, with defense research organizations, aspects of MOD being very involved with sponsoring a lot of PhD projects and research, over a decade ago, of which a lot of those have now turned into companies in the UK and the US. We have CEOs and CTOs that studied in university and academic environments in the UK, and some of those were sponsored and supported by the defense sector. We take it very seriously.
100% right. And UK was one of the first in the whole Europe. I recently spoke with Michael Cabot from National Quantum Computing Center, and he also mentioned and emphasized that the dedication of the government to create quantum very, very early, before rest of the country even were thinking about it. So you mentioned there is a lot of PhD programs sponsored by the defense. So two questions here. First of all, was the defense a trigger to create the national policy? And second one is, which university are the most focusing on quantum technology today?
Well, the UK, I think from your prior interview with the NQCC, you'll remember that the UK's set up around a lot of centres of excellence or hubs, things like the Quantum Technology Timing Hub, the Quantum Imaging Hub, the Computing Hub, and how PhD programs are set up as changes sort of from university to university. A few years ago, back in a decade or so ago, government and some defense research organizations would sort of partially sponsor or support some of these PhD programs. I think I was managing the technical output of about 40 different PhD projects at the time. And these spanned quantum computing, quantum sensing, quantum comms. So all of those three fundamental pillars that we sort of nowadays attribute to aspects of quantum.
So can you tell us a little bit more, what is the UK actually building today in quantum specifically for defense? And I mean, the real capabilities rather than strategy papers.
Yeah, well, it's hard to know what the defense organizations and research are actually building unless you're on the inside. But there is a significant interest in sensing and timing. The UK has a rich history in timing, as far back as even the days of the Empire with John Harrison and the H2 clock. We have an NPL. So we have a rich history in timing. There is a desire, I guess, to perhaps have a defense timing center. So a hope, you would think, to not necessarily be reliant on timing solutions on a commercial domain, or consider it as part of critical national infrastructure. So maybe a defense timing center, that would be very exciting. But yeah, they're kind of interested in all aspects. Of pushing, I would say, not higher TRL, but nearer terms to market technologies. So sensing and comms obviously are two of those closest wins that we can get. And quantum computing is somewhat still on the horizon for the useful applications, but we can buy and implement quantum sensing solutions today. And it's important as well, just to add to this, that we have to start thinking about it today. The average lifetime of a fast jet, or a helicopter, or a piece of military hardware is decades. These are going to be systems that will be, systems that are built today will be flying around in 2040 and 2050 and have upgrades through their life. So it's important to for these people to understand where quantum is going to be, not in 5 years, 10 years, but in 20 to 30 years, to make sure that it's enabled on these future platforms.
And if we look at the political environment, does UK stand with the NATO on quantum? And if so, on what position? Is that would be a leader, collaborator, or follower? Can you tell us a little bit more in which capacity of how they cooperate?
I'll do my best without stepping on any organizations with toes. But so the Strategic Defense Review came out last year, for exactly the time, I'm assuming September, October, and that was the biggest overhaul to defense spending that the UK has had in decades. And in that, we've taken what we call a NATO first stance. So we're very much aligned with the NATO vision. But the UK also, all members of NATO sit at the head of the table. We're clearly sort of a leading force in this, with our technological innovations and being able to sort of come to market. Other members of NATO clearly offer complementary skills with being able to sort of be fast deployment of systems. We're a sort of a leader, collaborator, but then there are also organizations like NATO TQC, the Transatlantic Quantum Community, which is currently, I think, headquartered in the UK, and it moves around between Denmark and the UK and various other nations as well. So we're very, very keen to sort of act as a leading collaborator, I would say, in the area of quantum.
That sounds great, and I like when you mentioned that all of these countries sit in the same table, and I can imagine that, and I think it should be like this because of the so many different modalities of quantum computing and quantum sensing and network and so on. So I think we can and we should learn from each other. But what's the real situation under the surface as well? Like, do you think like some of this country, even inside NATO, they are competing with each other?
Yeah, I don't think that's not something that people or nations hide, right? It's clearly, quantum has been defined as a strategic resource by most nations. The US have turned around just the other day, last week or so, for the sort of recommitment to the National Quantum Act. The UK has doubled down recently on a review of quantum spending and got another 2.5 billion or so in the spending pipeline.
Really? Because I remember the last number that I had in my mind was 1 billion, right? That UK actually committed to. And there were some critics' voices that if the billion is enough because Germany committed more and France committed more. So you said right now the government also doubled it down for another 2.5?
I would say I've always been one of those critical voices. The challenge with government spending is that, you get these top level figures. So the UK have now said that they've put in another, I think it's something like 2 or 2.5 billion. Some of that has already been allocated, but we have a new £1 billion for this procure program to sort of get the UK government to sort of acquire more quantum computing capability. But historically, the UK, France, Germany, they all do this, when a new financial year comes out or a new spending review comes out, you can repackage the same amount of money and just call it something slightly different. So what we do is spend a lot of effort to duplicate those. So when we see a new amount of money being added, we ask the question, is that new money or is that reallocated or recommitted funds?
Yeah.
The key point, whether it's new or recommitted, is actually an overall commitment for a long-term stake in quantum technology, computing, sensing, and comms. And the UK has done this to 2035 at least, and we'll hopefully see other countries follow suit soon, with the US and Germany potentially announcing new rounds of funding as well.
And in terms of the specific technology that the funding is going into in terms of research, you mentioned previously, obviously, sensing, you mentioned the timing and so on. Can we talk a little bit about specific use cases? Because especially in terms of the sensing, this is very interesting as well. I recently I had the chance to sit together and question Bill Vass from Booz Allen in the US. And he told me that quantum sensing is actually already developed industry. So I wonder what's your view on this, and what are those specific use cases that you see in your daily job, and yeah, just let's
Yeah.
stay in this.
Um, well, I would agree. Sensing has been around to be bullish on the subject, probably about 50 years, if not more. When we talk about quantum sensors, what do we really mean? Well, there are definitions as to what constitutes as quantum 2.0 or quantum and quantum sensing technologies. But a clock is a quantum sensor. A cesium fountain is a quantum sensor. We've had magnetometers, squid-based magnetometers for defense applications through DARPA programs since the 70s or 80s, probably even longer. So yeah, it's not a sort of a new technology. It's an overmatch and an iteration on existing, but there are brand new capabilities that can be had. We have organizations that have been established under the UK program like QLM that do quantum enhanced detectors for methane and gas detection. So that has obvious applications in the oil and gas industry for environmental monitoring. But you can also imagine advanced detectors, especially in the infrared region, to be LiDAR to be useful in a defense context for mapping out terrain or domains, leak detection. And similarly, it has applications in the medical sector. And we've seen quantum magnetometers. These can be used in the defense domain for detecting hidden objects, hidden metallic objects, perhaps underground or underwater. But you can also use them to map out the human brain. And there's companies in the UK such as Circumagnetics that have developed the equivalent of an MRI machine, but the size of a helmet that you can put on your head. And they are trialing these in hospitals to help do brain scanning on children that might not necessarily be able to sit still in a huge MRI machine for hours on end. So
100%. Oh, that's
there's lots
actually,
you can do.
and it can also be used on the battles, on the war zones and stuff, right? Where
Yeah.
whenever these big machines cannot be really transported or delivered. Okay, and then so let's imagine that there are some startups working on similar, applications. And I wanted to ask you, do startups really have a chance realistically to sell into defense right now in quantum, or this is still dominated by the larger contractor like Lockheed Martin and so on, similar to the weapon industry?
Good question. It's hard, right? There have been a push within at least UK MOD to open the doors, as it were, to other smaller entities, perhaps reducing the cost of trialing equipment on, even to take your equipment out to a field that is MOD approved, can be quite expensive and quite challenging. These large-scale defense primes, they know how to fill the paperwork and they know how to do that.
Yeah.
The SDR, the Strategic Defense Review, and various other sort of new initiatives through government are trying to sort of remove those challenging blockers that young startups will have. But ultimately, defense procurement is a difficult chain. Quite a lot of defense primes will go through bids and procurement programs at what you call cost plus. So they don't really make much on it. But I think that the real answer is actually less about these startups engaging directly with MOD and saying, buy my widget. They need to be engaging, and what is happening is with the primes to actually understand what it is that MOD or the defense customer really wants, and how you can integrate your quantum widget into an existing system. You can potentially sell it in a solution that does one thing, like a sensor that detects mines, perhaps. You could build that and maybe sell that. But if you want to implement or integrate your quantum sensing solution into whatever comes after, F-35, the fast jet, in another upgrade, or Tempest, or future submarines, the quantum technology startup's not going to be building a submarine. They're going to have to work with the systems integrators to
You can
integrate.
improve it, but they're not gonna build it from scratch.
Yeah.
Obviously, that's not only a budget, but knowledge and also huge teams working on stuff like
Yeah.
that in years, even in decades, right? Not even in years. Okay, that's make a lot of sense. So, if you can summarize the quantum for defense today, so do you think there are real capabilities versus strategic signaling?
I think so. We see a lot of strategic signaling out there. Part of the job is to cut through what can be done. Two great nations of the world, the US and China, tend to throw out a lot of information about what they can do. We saw this quantum heart murmur thing a few weeks ago. When the US rescued a pilot, China sends out a lot of information about what they can do with a quantum radar, which is not anything really, and what they can do with quantum comp. So a lot of it's signaling, but there is some scientific base and truth behind it. I guess the trick is to actually really pick and play to your strengths as a country and sort of pick those
It
winners.
is. That's actually my next question I wanted to ask you. If you think like that some of the government may a little bit overhype the capabilities to use quantum as a deterrent, kind of, right?
Yeah, I think my genuine thought on this at the moment is that quantum is still, whilst quantum can be used and it can be implemented, and we have, you can buy an atomic clock now, and they are helping map out high frequency trading. The real thing is we really don't know what we're going to do with quantum long term. So is it overhyped at the moment? Maybe.
Maybe.
But if in 10 years we look back and be like, wow, we didn't expect, there's nothing compared to what we thought it would, what we could do.
Yeah.
And I always liken this back to the initial kind of space exploration. And when
Exactly.
we sent man to the moon or put a few satellites in space, that was all fun. We had no real idea that GPS and GNSS and the mega constellations that we have now, that's a huge new capability that no one really saw coming. When the laser was first invented by Theodore Maiman in 63, 53, the very first real people, 2 years later, the laser weapon program came out. So the laser was invented, and less than 2 years later, three people in America were trying to weaponize it. But they didn't expect to see that lasers would end up going in compact discs or DVD players and form the backbone of our fiber optic, global network, because we didn't see that coming at all. So I think with quantum, you could be overhyping now, you could be underhyping now, but I guarantee whatever comes out of it, we won't necessarily have expected.
Thank you so much for all of this example that you mentioned. And I couldn't even agree more with what you said. I think every technology that was ever created by humanity, first of all, is trying to be weaponized by us sooner or later, but it also have a multiple of different applications that right now we cannot even see or imagine for quantum. So I like to think that sometimes the overhype is needed for that case, because the overhype is causing people to be aware and talk about it. And the more people talk about it, the more people starting to look into it deep. What can I do with that? And then where the solutions or new innovation are popping up. So I love thinking that sometimes the overhype is kind of needed and is helping the industry. Okay, but let's talk a little bit about the defense leaders in terms of countries and so on. What do you think the defense leaders are right now? What's keep them up at night? Is it more like that quantum will break the encryption? There's a lot of buzz and hype about this as well, definitely. Or maybe the sensing navigation advantages. What are they scared? Like, you talk to those people on every daily basis. You work with them closely. Can you tell us, like, what's keep them in line?
This is going to be a challenge one. And quantum, you have to remember, is still a very small part of a very small subset of the defense industry and the defense sector, right? So whilst there are a lot of, and myself included, porters have been evangelists of quantum, especially in the defense and security sector, it's still a challenge. So I would say two aspects. One, the board, the bosses, etc., of these, Lockheed and Thales and BAE, I don't think they need to be made more aware of quantum and the disruptive impact that it has. They've got other things to work that keep them up at night
More
and
about.
worry about. But the people that are working in defense, the quantum technology enthusiasts in the defense sector, I think that exact thing is keeping them up at night, is how do we communicate this message up, how important it is to high level decision making now, to make sure that our senior leadership and executive decision makers are informed enough about quantum in a coherent way that they can make a decision for the company to be position themselves to take quantum and make advantage of that in the next 5, 10, 15, 20 years. As I said, it's a weird thing working in defense because you have to be competitive today, right? You have to beat your competitors today and make money today for your shareholders and, have products. But also you've got to start these large scale primes already having to start thinking about what the next generation fighter jet will look like. So a 7th jet fighter, what is going to be being built in 2050 and 2070? What will that look like? And how do we, as the company, how does our company get involved in that kind of procurement framework? So you've got to be both really
pure research basically that have to be done on the government and academic environment, because as you said, this research take years or decades even, and a startup cannot very often survive the economical, situation here, right? Because they need to generate the revenue. They need to generate the revenue for their shareholders, for the VC that invest in them, and so on. So, okay. Another question, Joy, here is another buzzword that is very often overheard in the industry is the famous Q day. So can you please explain us, what is the Q day is actually, and what is the narrative? Is really actually influencing the policy decisions in a very meaningful way or not?
It really depends on, I change my definition of this depending on who I'm talking with and whether I want to scare people into making a decision or encourage people. And if I really
Please
wanted
scare us.
to be bold, I would say Q days sort of already happened. It happened when Peter Shaw developed the algorithm back in the 90s, right? As soon as that piece of maths came about, Q day happened, because it's only a matter of when it's going to be implemented. So we all know it's going to happen. It's not a single day or a point in time. It's a spectrum of events that have been occurring over the last 40 years to that point where we get the quantum computer of enough scale to break RSA 2048. That's one of the definitions. But we are moving to that day or that period, but the day is also moving closer to us, because as soon as a scientist or mathematician comes up with a new innovation, then that can move the timeline. So I would say it sort of happened the moment that paper was produced, and it's now just a matter of waiting until somebody turns the machine on to be able to do it.
Okay, that sounds scary. Okay, I hope that people will memorize that, what you said. Switching back again to the sensing, I wanted to ask you one thing that I think from investor perspective could be valid for LPs, for investors, and so on. So we mentioned previously that quantum sensing is already a developed industry, and there's a lot of going on, the real application and so on. So why, if this is the case, quantum sensing is still a little bit under the radar comparing to quantum computing? I'm talking here about the buzz generating, the hype, the press coverage, how people think, and even you work obviously in the best company, then they can predict and also assess the value of the market. Constantly what we see in those reports is that quantum sensing is at least double that size in terms of value for quantum computers. So why is so? Why is like that?
That's the $1 million question, to be honest. And that's the one that keeps me up at night. I think I've spent the last 10 years of my career in quantum saying exactly that, and saying exactly what great people in the UK like Sir Peter Knight have been saying for years of quantum sensing is already here. You can buy it. The market cap is it's smaller. It's currently higher than quantum because there's and it's nearer term. But ultimately, in the long term, quantum computing will probably have a higher market or higher TAM.
Impact.
But I, I think it comes from the nuanced point of the fact that you're competing in an existing market. The alluring thing about quantum computing, right, is it allows you to do things that historically you've not been able to do. That's what we'd call like a disruptive capability. There's nothing on the shelf that you can buy already that does this. Whereas quantum sensing or enhanced quantum sensing or quantum timing, you're competing against extant technologies and trying to sort of make them better. So you can do, in the defense world, you can do a few things. You can have what you call sensor overmatch. If I can see my enemy 1 kilometer or before he can see me, then
Yeah.
I've got 1 kilometer's worth of advantage. It means I can shoot first. The doctrine is see first, shoot first. Or you could have a disruptive advantage. Could I see the underwater domain using gravimetry and magnetometry and make the oceans, transparent to me? That's a completely disruptive capability. And in the area of warfare, they give advantages in subtly different ways. So I think to go back to your point, quantum computing has been kind of like sexier and hyped up. Quantum sensing has been more pragmatic in its deployment. And both are right, and both can learn from each other. I think the computing industry can learn from the sensing industry, and vice versa. So I would say sensing hasn't got the media. I think it's to say that they can both learn from one another of how they've gone to market.
So, Joey, basically what you said, this is very important, and I want to emphasize it because you actually say that quantum sensing will fundamentally change how the wars are fought. And obviously, we have a couple of global wars right now, and as you know, I'm originally Polish, so I'm very close to to following what's going on in Ukraine as well. And when you were talking about it, it just came to my mind that the drones change so much how the wars are today fought. So the question, I guess, here is when this is gonna happen? When do you think the real application um, or a breakthrough here?
Well, I think so. So to go back to the point, will it change the way we fight wars? I don't know. Fundamentally, there might be, as we said earlier, if you're overhyping it, what's going to happen in the future? There might be some disruptive advantage that we didn't predict, right? But the idea, for years, this idea of see first, shoot first. If I see my enemy 1 kilometer before they see me, then they just improve their sense, and you're just kind of building on this, doing step changes in capability until you've both realized, that you're really good. Will quantum sensing and quantum timing and resilient PNT can be position navigation and timing can allow us to operate in things like GPS denied environments. Now, will that change how we fight war? Probably not, but it might change how we plan a mission, or how an operator will enter a fighting or a war zone, because they now know that if they have previously, if they didn't have freedom of what we call freedom of operation in theatre or freedom of movement, then you're limited in what you can do. But if you can utilize a quantum sensing solution, then you've got freedom of operation or freedom of movement. And then that gives you new capability. It maybe gives you new missions that you can do. So will it fundamentally change the nature of war? Those kind of technologies, maybe not, but it will change the nature of what type of missions can be effectively delivered for the modern warfighter.
But that will lead us to the moment when the wars are something different anyway, I think.
Well, yeah. Years from now, we'll look back and be like, well, that's completely different to it might be everybody's just flying FPV drones at each other.
Yeah.
Or you might just do a quantum simulation and just say, well, the simulator says that we would win if we did invade or we did defend. So you might as well just surrender now. I don't know. But these small step changes cumulatively over a number of years, you will look back and be like, wow, that's a change.
There is so many different applications how actually this could be applied, and this is also all very, very interesting, and I really wonder how this will evolve in the next couple of years. But speaking about that and those applications, so do you think government are paying first for quantum sensing rather than the industry, or do you think the industry will catch up on that?
Oh yeah, no, I think government are still, the defense are
Winning
still
here.
that significant investor. There are revenue generating quantum sensing companies out there, but not much. The trick has been the shift, especially in the UK, and we're seeing this globally as well. The shift has been moving away from this, what I would call research-led innovation, to now procurement and requirements-led acquisition of systems. So rather than feeding out some money to make the labs, make the quantum sensor a little bit better, they're now starting to say, this is what we want to use it for. Can you build it for that? And if you do, we will buy it.
So is it a good moment right now in the UK market to start startup in the quantum sensing because of those procurements and this, government paying attention?
It's always hard to it's always hard to have be a startup, because there's a lot of there's limited availability and budget and money, and there's a lot of competitors out there, right? So you've really got to come up with your unique differentiator, USP. But I think it's still there's plenty of opportunity both in the UK, the US, Europe, and Australia for startups, because all you need to do is look at what we do at GQI. We map out all the things like supply chain and components capabilities, and you can identify what a nation or a country is good at and what they're missing. I would always advise any startup would say, just have a think about how many magnetometers are built in the UK, or would the UK require sovereign homegrown capability in that area? And if the answer is yes, then chances are you've probably got a reasonable business.
Another tricky question for you in terms of the adaptation and generation of meaningful revenue. Do you think quantum sensing will be here? It will happen in quantum sensing before the quantum computing in terms of, generating real big revenues?
That's a tough question. So when you say meaningful revenue, if you ask a startup, meaningful revenue is anything above zero. If you ask an investor,
break even is when we're above a zero, right? No, I'm talking about. Let me maybe precise the question. This is good that you mentioned. So right now, when we look at the public stock market in terms of quantum companies, right? So we have 4 or 5 maybe publicly listed companies, and only maybe half of them or less than half of them really generating revenue. The others are still, working on technology and so on. There is a couple of others. I think historically, the biggest number of startups going public in quantum industry this year, 5 or 6 or 7 even. I stopped counting, to be honest. There's new and new press releases popping up every day, which is obviously, it's very interesting and it's amazing. But the question is here, are they all gonna, generate a revenue as others publicly listed companies? So that's kind of revenue, not the revenue that startups are trying to scrap every single dollar or British pound just to prove that the concept works and so on. We know we are in a deep technology here, and the development of technology, it takes years. It's much longer cycle than other industries. It's not SaaS. It's not software. It's typical pure software or B2B2 software. So by meaningful revenue, I mean here the publicly listed company as a benchmark.
Yeah. Well, we have a number of, I think that I can't remember how many companies are publicly listed now. Quite a few, but
I think
there are
5
companies.
maybe?
Oh, I think more than that. I can't remember, probably a dozen at least. But there are some of them that I would call quantum all-play companies, and it's those ones that have a computing roadmap for long-term, have a supply chain or a hardware roadmap for components that are valuable, or have a sensing technology as well, or a clock and timekeeping. It's those ones that can fit and fill multiple customers, so multiple client requirements simultaneously. If you only sell one thing and you sell a quantum computer that's only going to be valuable in 2035, then that's not going to work very well for you. Well, it might do, but it's not going to be huge revenues in the next few years. But if you sell a clock or a comm system or an entangled network, now you'll be generating revenue and prove that you can do that until your large-scale quantum computer becomes ready.
Yep. No, that's % right. In the between when you're speaking, I also check. There's actually 5 companies listed right now in US. I don't know about the European market, right? But in the US, we have IonQ, we have D-Wave, we have Rigetti, we have Quantum Computing Inc., and recently, obviously, Inflection. It's launched. Yeah. and there's another cup of coin. So we are still on the beginning of the industry, right? But it's trending. It's growing. It's more and more startup popping up, and more startup actually landing on IPO, which is also good. Okay. So I'm just looking in the time. We probably should write up shortly, but I don't want to let you go, Joey, before we get at least one or two questions on the prediction. That's my tradition to grill my guests on the prediction, because my ambition is here to come back to those predictions in 5 years so we can compare and see who's right, who was
now
wrong.
you've put pressure on. You've put pressure on now.
Okay, Joey. What would be the first quantum technology that truly matter in the real world? And you can define a real world yourself.
Yeah, well, that's a good one. What will truly matter? Do I make a prediction about this? I'm biased, and I think it's already happened. We already have a quantum technology that truly matters, and that is in the area of timing and clocks. Timing, esoterically, is one of the most is the thing we all want and the thing we never have enough of, if you were to say that in a sort of philosophical sense. But it underpins so many aspects of modern life. We could not live without our ability to keep time to the way that we do. So what's the most real useful? It's already happened, and it can only get better, and we have to be aware of how reliant we are on time and timing solutions and time distribution as well, because it's still going to be a cornerstone of modern quantum computing and networking and sensing. All of them require good understanding of time.
20%. I like that. Let's take it here. Okay, another prediction, or maybe it's not even, it could be actually prediction. Okay, so I wanted to ask you if there is any country that you may see across, again, you have access to so many data through GQI, which I'm super jealous about, to be honest. So if you think, are there any country that quietly outperforming others in quantum defense or in quantum itself?
Quietly performing. I don't think there's any country that's quietly performing. I think a lot of countries make a big song and dance about their work in quantum, and they want to be perceived of as the best because they want to attract foreign investment and countries. I would say Japan. I really admire the Japanese ecosystem for quantum. That's probably the quiet one. I think because they've got the right idea. It's very Japanese in its writing, and I can't remember what the translation is, but it's something like quantum computing for the benefit of the people of Japan, or something like that. So it's very for the people kind of thing. So it's not defense related as such, although it will be. But they seem to have this more kind of like humanistic approach to quantum, and what you'd call a project management world, and agile methodology. Countries write down their plan, and this is what we're going to do for the next 10 years for something that we don't understand and might change. Whereas the Japanese program has been like, well, this is the goal, but we're willing to change it because we understand that the technology might change and our requirements might change with that. So I think that's that roadmap really inspired me, I think, when it came out. And it reminded me why I do science and quantum, which is to try and make the world a bit of a better place.
I like what you said. And I also really admire the Japanese work ethics. I think a lot of their success is coming with this ethics in mind. But I like when you said that there is very humanistic approach to the quantum, and I think I agree. I would even say is maybe holistic, and say like, hey, this is new technology, like, following by, we had AI and now we're going to go to the quantum, and quantum will have basically an adaptation with every single aspect of our life. So let's make it, with a human-centric first approach when we have our people in mind first when we deploy it and when we adapt it in every single part. So I like that. Yeah. I read about this recently as well. I think it hit the news so much. So okay, but once we are on the geopolitics, do you think there is something that can be so seen as first geopolitical shock caused by quantum? Is there any event that you can imagine that could cause like a shock?
Yeah, well, this is one of the things we say that accelerates what we call our Q-day timeline. So we spoke about this earlier.
Yeah, actually, yeah, Q-Day could be a global data shock. Yeah.
If there is a major, which we start to see, if there are major national initiatives for quantum, what we would call a quantum Manhattan project.
Okay, Joy, thank you so much. Our time's going to, because I think we over exceed the time anyway. So thank you so much for being us here. It was super interesting. And I'm really, really looking forward which of those predictions will be right. Hope we can meet again and sometime and compare it maybe together. That would be fantastic. That was Blond and Quantum. Thank you for joining me on this journey through the quantum business frontier. If you liked the episode, please review it on Spotify or Apple Podcasts and help more people discover the quantum world without needing to untangle the theoretical physics. See you next time! Unless the cat changes the timeline first.